Today we're going to combine a little bit of the old with a little bit of the new. In the last unit, we talked a lot about systems of equations and finding the solutions to those systems of equations. And in this unit, we've been talking a lot about matrices. Well, this section, we're going to be using Cramer's rule. This was published by Gabriel Cramer in the mid-1700s, and it's yet another way to find the solution to a system of equations. I can do this with a system of two equations with two variables, so x and y. I can also do this with a system of three equations, three variables, x, y, and z. So let's take a look at both, starting with Cramer's rule for two equations. Let's say I've got these two equations. a1x plus b1y equals c1, a2x plus b2y equals c2. So my a's here are going to be my coefficients on my x. a1 is going to be how many x I have in my first equation. a2 is going to be how many x's do I have in my second equation. The same is going to be for b's, for y. So how many y do I have in my first one? How many y do I have in my second one? And then c, there's just going to be some constant number that this is equal to. So c1 over here, c2 for equation 1 and 2 respectively. So I've got to find a few determinants. X is equal to this thing here, y is equal to this thing here, but I first want to focus on this bottom part that they both share, d. D is the determinant of this matrix. We're going to make a matrix where I've got column A and column B. Again, A's are my coefficient on x and B's are my coefficient on y. That is going to be the bottom part here for both of our fractions, x equals this and y equals this. So x is equal to, I've got to find another determinant, and then y is equal to, I've got to find another determinant here. But I want to see if we can see a pattern. D, remember, is my coefficient on x and my coefficient on y. Well, x is equal to, take a look up here. This is the same matrix, just replacing the A's with C's. Or in other words, if I'm looking for x, I replace the coefficient on x with the constants. I find this determinant, divide by whatever d is. And if I'm looking for y, take a look at this matrix. It's the same thing, only I've replaced the b's with c's. So if I'm looking for y, I replace the coefficient on y with my constants, with c1 and c2. I find whatever the determinant of this is, and I divide by whatever we find for d. Okay, this sounds a little complicated. Let's actually take a look at an example and see if it's any better. Okay, so here's an example. I've got two equations. First equation, 2x plus y equals 10. Second equation is 3x minus 2y equals 8. Okay, so the first thing I want to do, let's just label everything. So A's here are going to be 2 and 3. So I've got A1 equals 2, A2 equals 3. All right, B's are my coefficient on y. So this is technically a 1 here, so B1 equals 1, B2 equals negative 2. And my C's, this is going to be 10 and 8. So C1 equals 10, C2 equals 8. Then let's find D. D is going to be the determinant of your A's and your B's. So that's going to be A1, A2 for this column, B1, B2 for this column. Now for our problem, that means that D is going to be the determinant of 2, 3 in the left column, 1, negative 2 in the right column. Well, how do I find the determinant of a 2 by 2? I simply multiply this way, and then I subtract multiplying this way. So that's going to be 2 times negative 2 minus 1 times 3. Okay, I find d is equal to 2 times negative 2 is going to be negative 4 here. And minus 1 times 3 is 3. D is equal to negative 7. I'm going to put a little box around that just so I don't forget it. Okay, next, let's find x. X is equal to the determinant, and then instead of a1, a2, b1, b2, since I'm finding x, I replace the coefficient on x, so I replace a's with c's. So this is going to be 10 here and 8 here, and then these are going to stay the same. b1 and b2 are going to be 1 and negative 2. Okay, let's actually write what those are. So it'd be c1, c2, b1, b2 over d. So for our problem, x is equal to this determinant, 10, 8, and then 1, negative 2 in this column. And I'm dividing by d is negative 7. Okay, let's find the determinant of our numerator, 10 times negative 2, and I'm going to subtract 1 times 8. So this will be 10 times negative 2 minus 1 times 8 over negative 7. Well, 10 times negative 2, that's going to be negative 20, minus 1 times 8 is 8. So x is going to be equal to negative 20 minus 8 is negative 28 over negative 7. X is equal to 4. Now, there's a couple things I could do here. Since I now know x equals 4, I can go back to my original equations here, and I can just take x equals 4 and plug it into one of these equations to find y. Let's say I wanted to do that to the top equation. 2x plus y equals 10. Well, if x equals 4, 2 times 4 is going to be 8. 8 plus y equals 10, subtract 8 from both sides, you'd get y equals 2. So that is one way to do it to speed things up, but I also want to show you that you can continue to use Cramer's rule here to find what y is, okay, and we'll do it that way. So y is equal to, now it's going to be the determinant of a new 2 by 2. It's almost the same as this. Instead of a1, a2, and then b1, b2, since I'm finding y, I'm now going to replace the b's with c's. So this will be a1, a2, and this one will be c1, c2. And I'm still going to divide by d. Okay, so for us, y is equal to the determinant a1 and a2. Okay, so a1 and a2 are 2 and 3. And then c1, c2 are 10 and 8. And I'm going to divide by d is negative 7. Okay, just like any other 2 by 2, finding the determinant, I'm going to multiply this way. And then I'm going to subtract, multiplying this way. So that'll be 2 times 8 minus 10 times 3 over negative 7. Okay, 2 times 8, that's going to be 16. We're subtracting. 10 times 3 is 30. So y is going to be equal to 16 minus 30 is negative 14 over this negative 7. And just like we found when we plugged in x equals 4, we now have y equals positive 2. So that is using Cramer's rule for a 2 by 2. We can also do this for a 3 by 3, or in other words, a system of 3 equations with 3 variables. So that's going to be something with x, y, and z. Let's go take a look at that. All right, Cramer's rule for 3 equations. So a's are going to remain the coefficient on x. B's are going to remain the coefficient on y. Since I now have a third variable, z, this is going to be my c's now. And then it's going to be equal to just a number out here, d1, d2, and d3. Of course, these 1, 2s, and 3s are for equations 1, 2, and 3, respectively. And it's actually going to follow the same pattern as well. So I'll find x, y, and z, but before that, I notice that the denominator here all have this d. D in this case for a 3 by 3, okay, it's going to be equal to the coefficients of x, y, and z. So a's are your coefficient on x, b's are your coefficient on y, c's are your coefficient on z. You find out what that is first, and then to find x, you're going to take that same matrix here, and since we're finding x, we only just replace the a's. We replace the coefficient on x with whatever d is. So d1, d2, and d3 will go in this column. For y's, I take this same matrix, and I just replace the coefficient on y's. For z's, I take this same matrix, and I just replace the coefficient on z. So the c's will get replaced with d. All right, let's give it a try. I've got this system. First equation, 2x plus 5y minus z equals negative 4. Second equation, x plus y minus 3z equals negative 8. And third equation, 3x minus y plus 2z equals 13. Okay, so let's first label everything. I've got A, B, C, and D. Okay, all of these to look for. So A1, A2, and A3. This is going to be the coefficient on my x's. So 2, 1, and 3. Next, B1, B2, B3. These are my coefficients on my y's. So 5, 1, and negative 1. C1, C2, C3. These are coefficient on z's. So negative 1, negative 3, and 2. And I'm actually going to write d over here because I want it separate. Okay, and you'll see why I'm doing that. D1, D2, D3. This is negative 4, negative 8, and positive 13. Okay, let's find D. D is this big matrix here. Coefficients on x, y, and z's. So this is going to be my a's, my b's, and my c's. 2, 1, 3, 5, 1, negative 1, negative 1, negative 3, and 2. To find this determinant, I'm going to copy my first 2 columns over here. So that's going to be copying 2, 1, 3, and 5, 1, negative 1. Then I multiply the diagonals from the top left to the bottom right. So that's going to be 2 times 1 times 2, 5 times -3 times 3, -1 times 1 times -1. Let's write those down first. So I've got 2 times 1 times 2 plus 5 times -3 times 3 okay, plus -1 times 1 times -1. Okay, then I'm going to subtract going the other direction now. So that's going to be these diagonals. Subtracting -1 times 1 times 3. Subtracting 2 times -3 times -1. Subtracting 5 times 1 times 2. All right, plugging all of this into a calculator here, you'll get D equals -53. And I'm just going to put a box around this, save it for later, because I'm going to need it. Now, let's just start with x. So x is equal to the determinant of some big matrix here, and it's going to be pretty much the same thing that I see here. 2, 1, 3, 5, 1, -1, -1, -3, 2. Let's write that. 2, 1, 3, 5, 1, -1, -1, -3, 2. The difference here is if I'm looking for x, I replace the coefficients on x with what d is. So I'm actually going to replace 2, 1, and 3 with -4, -8, and 13. And now, to find this determinant, I'm going to rewrite this to the right. -4, -8, 13, 5, 1, -1. And remember, I'm going to divide this by d we found earlier is -53. Okay, let's find the determinant up here. So I'm going to multiply -4 times 1 times 2, 5 times -3 times 13, -1 times -8 times -1. Let me write all that down. So this will be -4 times 5, to the wrong spot, -4 times 1 times 2. Okay, plus 5 times -3 times 13. Plus -1 times -8 times -1. All right, then let's subtract going the other direction. So this is going to be -1 times 1 times 13, -4 times -3 times -1, and then 5 times -8 times 2. So let's write that down. So I'm subtracting -1 times 1 times 13, subtracting -4 times -3 times -1, and subtracting 5 times -8 times 2. And remember, all of this is still being divided by d is -53. Okay, so x is equal to, putting all of that into a calculator, you'll get -106. -106 over -53 And then dividing negative 106 by negative 53, you'll find that x equals positive 2. Okay, so that's x. We still have to find y and z. So let's try to find y next. Y is equal to big determinant here. Okay, I'm going to copy d again, 2, 1, 3, 5, 1, negative 1, and then negative 1, negative 3, 2. Okay, except I am finding y. So I'm going to replace the coefficient on y, 5, 1, negative 1, with d, negative 4, negative 8, and 13. So replacing this here with negative 4, negative 8, and positive 13. Then to find this determinant, just like all the others, I'm going to take the first two columns, rewrite them over here, 2, 1, 3, negative 4, negative 8, 13. And remember, I'm still dividing all this by d, which is negative 53. Okay, let's do some multiplication. I've got 2 times negative 8 times 2, negative 4 times negative 3 times positive 3, negative 1 times 13. All right, let me write all that down. 2 times negative 8 times 2. We're going to add negative 4 times negative 3 times 3. And then we're going to add negative 1 times 13. All right, then we have to subtract going the other direction. So that's going to be negative 1 times negative 8 times 3, 2 times negative 3 times 13, and negative 4 times 1 times 2. All right, so we're subtracting negative 1 times negative 8 times 3, subtracting 2 times negative 3 times 13, subtracting negative 4 times 1 times 2. And all of this being divided by d is negative 53 still. Okay, y equals. Let's plug this into a calculator. Let's see, that's going to be positive 53 over d is negative 53. Divide 53 by negative 53, and we get y equals negative 1. All right, then we can do this the easy way, which is taking 2 and negative 1. I now know x equals 2 and y equals negative 1. I can go back to my original equations. I can pick one of these, and I can just plug those in. Okay, if I were to plug in 2 and negative 1 here for x and y, that would be able to solve for z. Okay, but what I'm going to do is I'm going to show you that you can still find z using Cramer's rule. So I'm going to continue using Cramer's rule, but if at this point you wanted to just plug in x and y to find z in one of these equations, certainly you could do that. That might save you a little bit of time here. Okay, so let's look at Cramer's rule for z. z is equal to determinant, and I'm going to copy d again. So 2, 1, 3, 5, 1, negative 1, negative 1, negative 3, 2. So that's 2, 1, 3, 5, 1, negative 1, and then negative 1, negative 3, 2. Okay, except since I'm finding z, I'm going to replace the coefficient on z here. That means I'm going to replace these c's, negative 1, negative 3, 2, with what d is. So replacing that with negative 4, negative 8, and 13. So let's erase this. And I'm going to replace that with negative 4, negative 8, 13. And then just like before, let's find these determinants. The determinant here, so let's copy these first two columns. I'm going to copy 2, 1, 3, copy 5, 1, negative 1. Remember, this is still being divided by, d is negative 53. And now, do some multiplication. These diagonals from top left to bottom right are going to be 2 times 1 times 13, 5 times negative 8 times 3, and negative 4 times 1 times negative 1. Okay, let's write that down. So I've got 2 times 1 times 13 plus 5 times negative 8 times 3 plus negative 4 times 1 times negative 1. Now we have to subtract going the other direction. So that's going to be negative 4, 1, 3. Two times negative 8 times 1, and then 5 times 1 times 13. Okay, let's write that down. Subtracting negative 4 times 1 times 3, subtracting 2 times negative 8 times 1, subtracting 5 times 1 times 13. And this is all being divided by, d is still negative 53. Okay, plugging that all into a calculator, I am going to get negative 159. So negative 159 over negative 53. And when I divide negative 159 by negative 53, I get z equals 3. So our solution to this system of three equations is x equals 2, y equals negative 1, and z equals 3. Cramer's rule allows you to solve these systems of equations yet another way, this time using determinants and matrices.